Welcome everyone to our first seminar of 2026. I'm Jane Waite and I'm chairing the session. So in 2025, our research seminar series focused on teaching about AI and data science. And this is like an extra bonus one. We had so many amazing things and we really wanted Salomey to be able to share her research. So we kind of extended that particular seminar series so that Salomey could do this. What we've been doing is exploring what young people should learn about AI and machine learning and data science and examining research on the most effective ways to teach these essential topics in schools. And we've had some amazing talks, some fantastic talks throughout the year. And if you missed any, we highly recommend catching up on the recordings. It's been a real pleasure to see many of you joining us month after month. Thank you for your contributions, your questions, and the rich discussions you've brought to our breakout sessions. I am very pleased to welcome our speaker, Salomey Afua Addo, a third-year PhD student in the Department of Computer Science and Technology at the University of Cambridge. Her research focuses on exploring effective approaches for teaching AI concepts in junior high schools in Ghana. Her work engages with key themes in curriculum studies, teacher self-efficacy, teachers' pedagogical content knowledge, and she's contributing to the growing field of research on AI education in the African context. In today's session, Salomey will present findings from her 3-year PhD study on teaching AI in Ghanaian junior high schools, outlining the educational context and sharing unplugged learning activities that introduce how a simple neural network is trained. She will also discuss using storytelling to teach AI ethics and reflect on teachers' classroom experiences and the pedagogical content knowledge needed to teach neural networks effectively. We're very excited by this presentation, so we're looking forward to hearing about your insights. So over to you, Salomey.
My name is Salomey Afua Addo. I'm a third-year PhD student at the University of Cambridge, and Sue Sentence is my wonderful supervisor, and I get to draw from people like Jane and the rest of the RPSec team. So thank you very much for your contribution towards this work. Today, we'll be talking about developing unplugged resources to teach about neural networks in junior high schools in Ghana. So in today's talk, we are going to talk about unplugged AI in general, and we'll focus on AI education in Ghana. I'll give you a brief background to the study, and I'll give you a description of role play and board game I have designed for teaching about neural networks in schools in Ghana. Afterwards, we'll hear from teachers' perspective about the use of the resources in the classroom. I'll also describe the AI stories I have written to educate students on the ethics of AI, and afterwards we'll run down with a summary. So let's talk about AI unplugged around the world. What is computer science unplugged? So computer science unplugged are activities that involves teaching computing away from computers. So it involves the use of physical objects to illustrate abstract concepts. So we have various unplugged activities that could be used in the classroom, like role-playing computation, puzzles, games, riddles, and magic. So let's talk about AI Unplugged. So AI Unplugged is not entirely new. There are some researchers who have developed activities to teach about AI in the classroom. So an example is Anna Lindner, who designed AI in a box for students to learn about how to, determine or recognize AI applications. Also in Germany, we have Professor Sylvia Joachim, who have designed unplugged activities to teach about the algorithms of machine learning. So we are talking about algorithms like k-nearest neighbors or decision trees. Also in the US, MIT have designed unplugged activities for teaching about AI concepts. So they have Pastaland for teaching about decision trees, and they also have neural networks. Learning through unplugged activities has many benefits. One of them is that abstract concepts could be made concrete. It also provides kinesthetic engagement in the classroom. Students are able to, touch objects, and research shows that it supports learning. Learning can be presented in real context. It's helpful in low resource environments. And last but not least, it is engaging and fun. So now let's focus on AI education in Ghana. So this is the map of Ghana. So Ghana is located in West Africa. Basic education is compulsory in Ghana. Now, junior high school education is part of basic education and is designed to equip learners between the ages of 13 and 16 with academic skills in reading, writing, arithmetic, problem solving, and creativity. In the year 2010, the government of Ghana, through the National Council for Curriculum and Assessment, introduced an ICT curriculum. However, in 2021, they saw a need to revise this ICT curriculum into a computing curriculum for basic schools. Now, this curriculum features modern computing topics such as programming, algorithms, artificial intelligence, and robotics. Now, artificial intelligence is a substrand in the curriculum. So this is a breakdown of some of the topics that students are expected to learn during AI lessons. So in Basic 7, students are expected to discuss applications of various areas of AI and also discuss the uses and importance of AI to society. In Basic 8, they go a little bit deeper into talking about artificial neural networks and comparing intelligence in humans and machines. They also discuss the difference between strong and weak AI. Now, when they get to Basic 9, they go deeper further in the sense that they are exposed to knowledge-based expert systems, and they also get to play with machine learning. In 2024, I went to Ghana to conduct a case study on AI education in a district in Ghana called Tema. During my visit to Tema, I got the opportunity to interview computing teachers, and they reported that although AI has been introduced in the curriculum, they have not received sufficient AI-targeted professional development. One teacher actually told me that teaching about neural networks was particularly difficult for him or challenging for him. Now, on the board is a teacher in Basic 8 who is teaching about neural networks and the difference between human intelligence and machine intelligence. I sat through his class, and then he was teaching about these concepts using a marker and a whiteboard. So I came back to the UK, and then I was looking through the resources available for teaching about neural networks. And there are existing online resources relating to neural networks. However, I wanted to develop resources that were contextualized to Ghana. So in the next talk, I'm going to talk about developing these unplugged resources to teach about neural networks within the Ghanaian context. In 2025, I developed a role play and board game as a tool for explaining how neural networks are trained for students in junior high school. So these resources were developed through an iterative process with many rounds of feedback. I piloted the resources in the UK with education researchers, and I know there are some on this call right now, so a big thank you to you for your participation. I also engaged AI experts in my department, the Computer Science and Technology department here in Cambridge, and also engaged 2 computing teachers in Ghana online. Further, in 2025, I piloted the resources with 43 computing teachers at a teachers' workshop in Tema. 10 of these teachers were observed in the classroom, and later I interviewed them whilst they were observed in the classroom whilst they used my resources for teaching about neural networks. And then afterwards, I got to interview them. So I'll be sharing some of their feedback with you in this presentation. So the primary learning objective was to help students identify and distinguish the processes of forward propagation, evaluation, and backward propagation involved in training a neural network. So the resources represent an effort to demystify the opaque nature of neural networks without relying on mathematics or programming. The focus is on developing teaching materials that are contextually and culturally relevant without depending on ICT infrastructure, because some schools do not have robust ICT infrastructure. So they don't have computers or they don't have internet running. So the picture here is me in a school trying to teach about, talk about neural networks casually to the students. And I really enjoyed that experience. So I'll briefly talk about the role play and how it's conducted in the classroom. So the role play is an activity within the context of farming and crop disease. Now, Ghana is a cash crop producer. Students and teachers know about farming. They learn about farming in the curriculum. So it is a concept that is familiar to them. The purpose of the role play is for players to identify features that are relevant for detecting disease on a cocoa tree. Now, one thing about unplugged activity is that there has to be a problem involved. There has to be a challenge they want to solve, and this is the purpose for the activity. Now, students take on the role of supervisor, input layer, hidden layer, and output layer. As you can see on the slide, you can see an image of students holding the ropes. They have formed their network. We use ropes and cards to record the data set and also to facilitate connection between layers. Let's talk about the data set. We cannot talk about training neural networks without having a data set. So I developed a toy data set for this problem. So this data set is about a farm scenario. The features represent temperature, spot, fertilizer, leaf color, distance, and family farm. The data is numerical because I don't want them to experience neural networks entirely from a qualitative, approach. I want them to have a feel of the numerical approach because that's what happens in a real world. Real world neural networks involves numbers and not words or text. So the data set was a numerical one. Now the features are easy for students to understand. For instance, for feature A, which is temperature, it says that is the temperature suitable. So 0 stands for no and 1 stands for yes. We have 6 features. Now, among these 6 features, 3 are relevant to predicting whether there's disease, the presence of disease or not. And there are 3 which are noisy. Now, we design it this way to mimic the real world, that in the real world, data is not always pure. There is some form of noise in it. Great. So now I'll talk you through the forward propagation, and then I will demonstrate that to you. So first and foremost, the supervisor is presented with the data table. So the supervisor has ownership of the data. Now, nobody sees the data except for the supervisor. We built the supervisor in this game because this is a supervised machine learning problem. So the supervisor picks the data set and gives the input layer, gives the input neurons within the input layer their data point. So the input neurons take these data points and they record it. Then afterwards, they pass these data points to the neurons in the hidden layer. Now, in real world, within the hidden layer, that is where computation happens. So each neuron first computes a weighted sum of the input values and then apply an activation function to that result. For students in junior high schools in Ghana, they are not exposed to weighted sum or activation function. So we have to find a way of introducing them to computation in hidden layer that is accessible. So we came up with the concept of random selection. We chose the concept random because in real world, for first iteration of training a neural network, some of the weights are randomized. Now we ask them to select 3 out of 6 because these weights could be 0. So after the hidden layers have done that computation, they pass the information to the output neuron. And it's within the output neuron that decision is done. Now we've designed a heuristic or decision rule for how the output neuron is going to make a decision based on the data received from the hidden layer. From there, there's a need for evaluation. So at the end of the feed-forward stage, the output layer evaluates how well the network performed by comparing predicted output to the actual value. This is analogous to using the loss function in real world to calculate or assess the error of the network. So I know that some of us are not really familiar with neural networks, so I decided to do a quick demo of how the role play is done. Now you can see that I have the input neurons here. We have the hidden layer with the hidden neurons, and then we have the output layer. Now A, B, C, D, E, F are input neurons. G, H is the hidden neurons, and then I is the output neuron. So first and foremost, what the supervisor does is that it gives the data points to the input neurons. So after the input neurons have received the data set, they write it down, and then they pass it on to each of the hidden neurons. So this neural network is a fully connected feed-forward neural network. So each input neuron gives their data to all the hidden neurons. So from there, we do the random selection computation. So G randomly selects A0, D0, and E1. H does the same, B0, C1, and F1. So after that random selection is done, they pass this information to the output neuron. So when they pass this information to the output neuron, what the output neuron does now is that it asks itself, what is the majority value that the hidden neurons pass on to me? So G contributed 0 because it gave A0, D0, and E1. So the majority is 0. And then H contributed 2 ones and a single 0. And so the majority value is 1. Now we use our decision rule. Our decision rule says that if these two values are 0, then there's no disease. So the prediction is 0. But then if one of the values is 1, so either 1 is 1 or both are 1, so at least 1, then there is disease on the crop. So in this case, because it's 0, 1, we'll say that there is disease on the crop. However, the supervisor checks the table and realizes that actually there's no disease. So that is the end of the forward propagation. So after the forward propagation, they have to do the back propagation because they're trying to train their neural network. So to do the back propagation, after the error of the network has been calculated, the error is shared back through the network on a layer-by-layer basis until it reaches the input layer. Now, as a researcher, modeling backpropagation for students in junior high school level was quite challenging for me because it involves calculus, which is something that the students don't know at all. And so I relied on MIT Ray's depiction of backpropagation in their role play activity. Now, in their approach, they use a concept I would call a structural credit assignment problem in real-world neural networks. But however, they broke it down to the concept of establishment of trust. So I would demonstrate that to you here. So this is the board game. We've done our feed forward. We've done our forward propagation. Now let's do our backward propagation. So to do the backward propagation, the supervisor tells the output neuron that the actual is 0, but you predicted 1, that is an error. You have to distribute the error or the feedback to the other neurons from hidden to the input neuron. So what the supervisor does is it scores each of the hidden neuron. So it asks itself, how many correct signals did G contribute towards I? So the correct signal, like the correct output or the ground truth is 0. There's no disease. So G gave 2 zeros and a single 1. So it calls it 2 out of 3. Now H also gets scored. So because it gave it 1 positive signal, it scores 1 out of 3. Now what happens next is that I adjust its connection to the 2 hidden neurons. So it connects with G and then connects with H. But you could see that its connection with G is much stronger than its connection with H, sorry, because it trusts G better than H. Now, it doesn't end here. The hidden neurons have to also give feedback to the input neurons. So let's start from G. G received A0 from A and then received 0 from D. So it establishes trust or a stronger connection with these 2 neurons. And then with H received 0 from B, so it also does the same. So this represents the end of backpropagation for the first iteration. Now, when you're training a neural network, you don't just end at this stage. You have to give it more data for it to learn. Now, for subsequent training phases, what happens is that whenever we do our feed-forward propagation, because this system is learning, what it does is that G will always prioritize A and D because it trusts them better. And H will also always prioritize B because it believes that it receives positive feedback from them. So students are allowed to play this game for about 5 times, and then they record their prediction. So what we have here is a copy of a student's board game. So now what I've demonstrated is how the game is played, without the human beings. Because I realized that this game can be played without like all human beings standing, aligned. So I decided to reduce it into a board game where they could play it in pair. So some students explored the role play, others also explored the board game. So this is an example of the board game by some of the students. Now you could see that the students have played, I think have done 5 phases of training. And then you could see that the student is learning features such as A, B, C, and D. Now, when we look at our data table, A stands for temperature. Temperature is important for disease prediction, disease prediction in cocoa crops. B stands for spots, so whether or not there are spots on the leaves. So B is a relevant feature. However, C, which stands for fertilizer, is not a relevant feature. It does not have any bearing on whether there'll be disease on the crop or there'll be no disease. It's not a strong predictor. Now, D is the leaf color as to whether the color is green or not green. So it's also a relevant feature. E and F are noisy features. Diseases have no bearing on the distance from the farmer's house or whether the farm is a family farm or not. So we can see that from this board game, the students have identified that A, B, C, D are relevant features. And then we get to explain to the student that your network is learning a noisy feature, which is C. Now so I visited about 10 schools, and some of the schools explored their board game. So these are some samples of how the board game looks for some of the students. Now, I realized that actually when we take our time to, add on to this activity, we are going to provide high ceiling. What do I mean by high ceiling? There's more opportunity to teach about concepts in machine learning, such as overfitting, underfitting, and what a good fit is through this activity. because when you look at the board game to my left, this one, you could see that the student is learning from, I think, all the features. I don't know how they did it, but if you check their evaluation, you could see that for the first iteration, they got it wrong. Second iteration, they got it right. Third iteration, they got it right, but the fourth and the fifth, they had it wrong. So they were learning the noisy features, and so they were not getting the right predictions. Now let's go to the extreme right. In our extreme right, you could see that this student is learning a lot of noise because it's learning from E and F. It's not learning at all from D, which is a relevant feature. Now, when we look at its evaluation table, we when we look at their evaluation table, we can see that for the first iteration, um, they had it wrong. For the second iteration, they had that wrong. Third iteration, they had it wrong. And the fourth iteration, they had it wrong. So they were just like learning the noise, so they couldn't, uh, they weren't able to get a right prediction. But when we look at the board game in the middle, we could see that for the first iteration, they had it wrong, but subsequent iterations, they had it right. So this could be an opportunity for teachers, sorry, to introduce the concept of overfitting, where during the training phase, the model really learns the relevant features so much that it may not be able to generalize on unseen data. And we can also talk about underfitting, where the system learns from the noise so much that it's not performing well even during training. So how were these resources evaluated? We evaluated these resources from the teacher's perspective. So we organized 2 workshops with 43 teachers where we assessed their self-efficacy beliefs to teach about neural networks using a pre- and post-intervention survey. We had 39 teachers completing this survey, and the results showed that the statistical significance that teachers have increased their self-efficacy beliefs after the intervention was given to them. Now, 10 teachers implemented the unplugged activities in their classroom, and we conducted 10 post-observation teacher interviews to obtain teacher feedback. So these are some of the feedback that we received from the teachers. So the first, one of the teachers said that there will be a need to simplify the instructions. Another teacher says that the role play is effective for classroom demonstration of neural networks. He said that he particularly liked how the children had to align themselves, the input layer, hidden layer, and output layer. And he also likes how they did the propagation because students could see how data is passed forward and also the feedback is sent backwards through the network. Another teacher finds the activity to be learner-centered. So Judas used the board game in his class, but then he said the children did all the work. You know, what he had to do is to walk around them, check what they were doing, and help them to understand. Another teacher mentioned that it helps support diverse learners. So he cited that there was a boy in his class who does not participate at all in his lesson. But in this particular lesson, when it was time for them to do the role play, he volunteered to participate. So he was one of the hidden neurons, and then he was able to, get engaged and give feedback, which he has never seen him do that before. So he feels that the role play activity is good for the diverse learners in his classroom. Now let's talk about developing my AI stories to teach about AI ethics. The first story that I had written is about who do you trust, and the emphasis of the story is the importance of fact checking in the age of AI. When I presented this story at the teachers' workshop, and also when the teachers presented the story to the students in the classroom, as an observer in the class, I could see how students could relate to the fact that it is important to fact check. Because in one of the lessons, the one student asked her teacher that how come that when she asked ChatGPT to help her with her Ghanaian language assignment, it always gets it wrong. So the teacher have to explain to her that, the data used to train those systems is not based on our Ghanaian language. And so that may be the reason why the system does not get to, help her complete her Ghanaian language um, assignment. And so there's a need for them to always fact check, because these tools, although they portray themselves as they know everything, but sometimes they may be wrong. This second story is about training of linguists. Now, I would say that this is still a work in progress, because when I introduced it to the teachers, although I had some good feedback as to how I introduced some cultural elements into the story, but I feel that I have to rework the story and present it to both teachers and students. But the core thing is that when I sent this story to the classroom, one student saw a proverb in Akan. The proverb says, "Wofru dua pa a na yepia wo." Literally, it means that when you climb a good tree, you are given a push. But contextually, what it means is that people with good intentions have to be supported. This story is about linguists in a palace. So if you go to the Ashanti Kingdom in Ghana, the king does not address people directly. So the king has got a linguist who interprets what the king says, to the ordinary people in the palace. So the linguist is more of like a chatbot, so the linguists have to be trained, because the king speaks in proverbs, and the linguists have to be able to give a contextual interpretation. Now, these linguists also have to be trained by, the elders of the land. And so we see that in terms of ethics, we see the role of elders and councils as oversight structures. They help to form opinion in society, but then the decision making is based on the individual. And so I think that this story could help children know that AI shouldn't be a decision maker for them. They could use AI to form an opinion, but then making decisions have to come from them personally. Secondly, we also think that the use of proverbs to illustrate that meaning requires contextual interpretation rather than literal acceptance is linked to what kind of data is used to train your neural networks or chatbots. If this data is not embedded within um, the Ghanaian culture or the Ghanaian community, then whatever feedback is going to give to its users may not be contextually relevant. The next thing is traditional apprenticeship. So these linguists are first trained, by the elders of the land. And whilst they are being trained, they build gradual trust. They don't just accept whatever is given to them. And so we have to we teach children. And so this story is an opportunity to let children know that you don't have to just trust a system, right? You have to take your time and test it before you actually try and build trust with it. And we also teach them the importance of supervision and accountability. Now, these cultural elements and their relations to AI could make students become more context aware, conscious, and accountable when they use AI systems in their everyday lives. So I will highlight some teachers' feedback about the use of AI stories. So one teacher, after he used the AI story in the classroom, says that he could use it as an assessment tool. So the children read the story and they explain how the story is related to AI. Another teacher, Danny, says that he feels that there are some technical words in the story, so there'll be a need to eliminate those technical words or break them down. Josephina finds the stories to be relatable. She says story is life. It is part of life, whatever you read in a story. So children are able to, relate with stories more. And then it makes them think deep and they're able to engage other senses, their emotions in the classroom setting. So I cannot finish this talk without quoting Josephina, because Josephina is one of the few teachers who was able to use all three sets of activities in one lesson. So she says that when it comes to the story, you realize that the story has all literary devices. So there was some kind of suspense. They would want to know what will happen next. So that technique alone will sustain their interest. And then when it comes to the role play, because it is activity based, the children get involved. They are part of the lesson, so they learn. And the board game is collaborative. They are working in a group. They all have diverse ways they contribute to the lesson. So, in summary, before I summarize, this picture is how Josephina was able to arrange her children to stand, in line as input layer, hidden layer, and output layer. And I really liked that approach. Now, in summary, AI unplugged activities are useful. They're useful tools for teaching about AI in low resource settings. They are effective for demonstrating technical concepts in AI, such as neural networks, without the use of computers or the internet. They foster classroom engagement and learner-centered learning. Last but not least, they promote inclusivity and diversity in the classroom. I am currently analyzing data collected for this study, and I look forward to continuing my work on developing resources for teaching AI concepts in K-12 educational settings. Thank you.
That's wonderful. Thank you, Salome, for your fantastic presentation. Can we give her a little round of applause? That would be amazing. And I'm very excited to say that we've got a new seminar series, which is starting for 2026 next month. And its kind of short name is Applied AI, with the idea that we're focusing on how to teach about AI across the curriculum. But instead of looking at the research done in computer science, where we're kind of pushing it into other subjects, we're trying to find people who are researchers in other subjects. So maybe they're from a policy perspective or a history perspective or art or engineering. And they're trying to see how they can pull teaching about AI into their discipline. So it's this idea of looking at these other disciplines, including the arts, the sciences, the humanities, and how they're trying to draw AI education, AI literacy, teaching about AI into their subjects. And we're going to kick off the seminar with Tamar Monroe-White on the 10th of February. And she's going to be talking about things from a policy perspective and how important it is for people in policy. So when they're training people to make big decisions about our lives, that they have to understand the ethical and equitable side of AI design. So if you'd like to come along, please do, and please tell your friends.